Hi, this is Steve giving you a simple demo using Angular 2. What we're going to do is we're going to write a simple application whose architecture is based on components, templates, directives, event handling, property binding, dependency injection, component communication, and reusable services, reusable components. And basically what we're going to do is have a child component call a web service and get web results to display on its template. And then what we're going to do is define a parameter in the parent component and submit that particular limit parameter, which will update the application root component attribute, which will then propagate back to the template, get passed into the child template, and the child component attribute gets updated, and then a web service is called with a new parameter for a new web service result. So we use a lot of nice features of Angular 2, and so let me just show you the application in action. This is the front end of the application. It has a main root component which defines the limit, submit. Inside its component there's a child component. The child component is very self-contained. It will call the web service and display results using a configuration parameter limit which begins at 10. So it will display 10 rows of the web service response. As a matter of fact, it calls the web service, which yields 10 rows of results. Basically, the application is going to demonstrate how you can define a form on the application component, the root application component, submit a value which updates an attribute of that component. The updated limit then gets propagated back to the child component template and gets passed through the child component template through an attribute. And the rendering of the child component shows a new table with a new number of results. Okay, now notice, I'll just point out that the web service could have been called in the application component, could have been called in the child component. The web service presently is called in a reusable MyPlaces service, which is injected into the child component. So the child component can be reusable in a number of different ways. It can call its own web service and display results using its own configuration, or it can use a reusable service which calls an Angular 2 HTTP service, in which case the MyPlaces servlet, which renders some of these rows, can be called in different components from any component, rather, as long as it gets injected. So let's go through the application code, and I'll show you. This is my project. I use WebStorm. I am not transpiling in the project right now. What I do is I transpile and I compile upon browser load. So first let me show you the index.html. The index.html renders the title, New York City subway locations, and it uses the system.js loader to import an app. What is app? And also notice there's an app tag here, which is an Angular tag. It's a custom markup fragment that Angular has an Angular implementation. So what is this app, and is it the same as this app, etc.? So let's look at the system config. The app that I'm loading really is main.ts. It's the main application that's getting loaded is up here. The system.js loader is basically loading a bunch of modules for me from different locations. I'm using Angular Core, I'm using Angular Forms, I use an HTTP service from Angular HTTP, I use the browser module to do Angular compiling, I use the dynamic browser platform browser dynamic package to bootstrap my application. I also define my TypeScript targets and modules, etc. here. Most of the time, I'm just changing this to point to the application I'm loading, and I'm changing these things to determine what I need in my application. So let's go back to index.html and let's just take a look at this. Okay, so system loader is loading apps pointing to main.ts. So let's look at main.ts. What main.ts is doing is it's bootstrapping an application module. An app module is defined by this class, and it's bootstrapping actually the root component. So it has to import everything we need to run our application. It's importing the browser module, the ng module for annotations, HTTP module to use the HTTP service, uses reactive forms module to build forms within a component, and then I have 3 custom things that I'm importing here. One is an app component. The other one is its child MyPlaces component. MyPlaces component calls a service called MyPlaces service. So these are the 3 files that I'm really custom building here. So let's start taking a look at them. So what does ng module do? It imports the featured modules that our application module is going to use. It declares the custom components that I'm going to be using. It defines MyPlaces service as a provider so I could inject it into components. And it also tells me what's getting bootstrapped here. It's app component. So let's take a look at my project. I've got application component, a MyPlaces component. I got a config, a service, test data. Test data is just some dummy data I could use for the web service result. I'm not using that right now, but it's good to be able to see it and understand what your JSON objects look like. I have a URL configuration file which basically points to my URL that I'm going to use to call the web service. This is my web service URL. I also broke it down into pieces because the number of results I'm getting back from this web service, I want to vary that because I'm going to eventually do pagination with the MIND table, and I want to make sure that I could list 20, 30, 40, 50 rows and demonstrate the pagination functionality in Angular. Okay, so let's go to the application component. This is the main root component. This is the one that defines the selector, app. It's the one in my index.html. The annotation says, this is the app tag, this is the template, this is the style sheet, and this is the class that's used to instantiate the component that's coupled with this template. The application component consists of a form model. A form model is a backing object for a form. It's used to contain the data for the form that I'm going to be implementing in my application component template. I also have a string attribute here, which is being used for the limit. My constructor uses something called a form builder, which gets injected into my constructor, and my form model uses form builder to construct its form model, and it simplifies the way I could create the form by just listing the attribute, its type, and its validator, etc. Now, after I create the form model, I have to go back to the template and map the form with the form model in my component. So if we look at the template inside the application component, what we see is the form group of the form is being mapped to the form model in my component. So that's what this syntax means. On an event where you click, I want to submit, I want to ignore the default validation because I'm going to do my own validation. And in my form, I do have a button which does submit, but I also have an input parameter, and I use this attribute called form control name to point to my limit attribute in my form model. So this input value is mapped to my limit in my form model. When I submit it, it updates the attribute value in my form model. And then, of course, if there's a problem with the form model, I'm going to either show a span or hide it, depending on the result. So I asked my form model, do I have an error with the minimum length validation of this attribute? So it's a convenient way to show an error if there's an error. Okay, notice also that the template of the application component has a My Places tag. This is a child component that corresponds to my My Places component. This tag is defined in My Places component. So since the parent template is using the child template, My Places, it's capable of communicating with it. And the way we're going to do that is we're going to pass the value of limit to an input parameter in the My Places component whenever that limit of the parent component changes. So the way it works is I have an input parameter. I click submit. The value goes back to the application root component attribute limit value changes. Change detection says, hey, reevaluate the templates, and when you're doing that, you're passing the new value of limit back to the child, and that thing is mapped, let's say wired to the row number in the My Places component. So it's more like the data is getting communicated through the templates. But it's really component template. One's a child of another, and you can do the communication as long as you're in one router outlet, I guess. Okay, so let's take a look at the My Places component. We import everything we need from My Places component. Okay, so we need the component. We need some stuff from the Angular core. We need simple change, on changes, input component. We need observables from the RxJS package. We're calling web service. We're getting back an observable. This component needs the observable type. We're using a map because we're mapping that result to a JSON object. And we need configuration. We might need a configuration data so that we can display information, use it to call web service, etc. The component has a selector called My Places, and that's why we are using the tag in the parent template. We point to the existing template for the child and the style sheet for the child, and then we define the My Places component by implementing on changes. And here's the important thing. The annotation at input says this is a value that's going to be an input to my tag, right? So this is how you wire the parent to the child. Through the template argument, it's going to update my row number value via this annotation. I have subway stations array. This is what's going to be used to render the template view. Anytime the subway station changes, the template's going to get updated. I need this observable data source because my web service returns an observable, and I need to subscribe to that so the web service could get called. And I have an app limit, which is a static configuration. I have a dynamic final limit based on what the parent's sending me. And so let's look at this object. It's got a constructor, it has an onInit, and it has an ng on changes. So the life cycle of this object gets constructed. In the constructor, I call get subway stations my place of service. Where do I get a handle on this? Well, the my place of service is a provider in my app module, so I could inject it into my constructor. The private my place of service tells TypeScript, give me an implicit variable. Give me a variable implicitly that represents the my place of service. The injection is going to instantiate an object, my place of service, and set the my place of service attribute to that reference. So that's why I can make this call and call get subway stations. But this call returns an observable. And so the HTTP service really didn't get called yet. It's not until I then initialize my object where I actually subscribe to the observable. In doing that, it returns a data object, and that's an array of data which gets put in my subway stations. Now, at this point, my template is rendering. Angular is rendering my child component at this point. Okay, now the other important thing in this particular object is that when the parent component sets the limit, let's go look at it again. When I go and change this and I submit, basically I've changed the limit in the parent object, and the parent object said, okay, I've changed that. Now I've got to go pass that new value to the child template. And now the child template basically says, okay, I've implemented on changes. Tell me when that change happens. So the change does happen. And when it does happen, this ng on changes function executes. And what I do here is I say, okay, if the row number is not proper, use the default configuration of the app limit. Else, use row number. If parent gives me a new row number and it's injecting a new value, I'm going to use it. So this final limit is either the originally configured value 10 or it's a new value that I just typed in. And based on that, I call the web service again, and this time I pass in the final limit because I have another function there which allows me to define a dynamic URL inside my service. And this time I subscribe right away to the data source, and I update my subway stations. So as changes happen, subway station changes, and that's why you see the behavior that you see. Now notice I rendered the row number here so I could verify what I'm seeing there. So let's do one more thing with this little simple application. Let's look at what the web service looks like. As you remember, in my main.ts, I listed it as a provider. In my places component, I used injection to inject it into my constructor. And I called it. Notice since this is private, I created an implicit variable with a my place of service. So even in the ng on changes, when I call it, I have a this.my place of service here that I could reference. Okay, let's go to the service real quick. So here's the service. It's a reusable service. I inject the HTTP service into the constructor. Okay, I still need these things: the observable, I need the map, I need the service URLs, and I need injectable because I'm defining the MyPlaces service to be an injectable. In the class, I define attributes that I need to dynamically create a URL. I still need the observable here. So in my constructor, what I do is I inject an Angular HTTP service. I define a private implicit variable HTTP that I could use. I construct a dynamic URL inside my constructor. And then my get subway stations function is basically going to use HTTP get on my dynamic URL, take each result in my array and map it to a JSON object and get the resulting array observable and return it. So notice this returns an observable. When I call the second time on the onChanges function, I need the limit coming into the function, and I do HTTP get again, and I use the dynamic URL again, but I still return an observable. This return type is observable. Now keep in mind, I'm flipping back between the original configuration parameter limit and the dynamic limit that's changing. Okay, so that's this particular example. So now let's go to the next example. The next example does the same exact thing. Notice here. Let me re-render it. Notice it starts with its default value 10. I could use pagination because I got some new controls in here. It's the same type of app. And I could scroll through the results. Now notice I lost my row number that I was rendering. I kind of wanted to keep it, but I did lose it. So let's go and look at that example real fast, and I'll show you what I had to do to make that work. So I put it in a different project because I didn't want to break my provider project, and I want to. I had to make sure that I started creating the using new packages, and I didn't want to break it because sometimes you do npm install and sometimes things don't go the way you want it to. So I try to preserve my package.json file to something that works that I really want. Okay, so let's look at this application. So let me clear the slate. So what did I do to create to introduce this functionality? First, I used a pagination module out on the internet, and I added it to my packages as instructed by the author. My package.json, once you install that doing --save, your package.json will update, and you'll eventually see it there in the dependencies. And so it's good to keep your package.json file in sync. And once again, nothing changes here. It's the same old app. What did we change? Well, in the app module, I had to make sure I imported pagination. I had to import it. Everything else is pretty much the same here. And the only other change that I did in my places.html, I have my ng4 directive, and what I do is I pipe it through this pagination component. Add this, you'll get pagination with the control. So the items per page is 5. The current page is this page variable, and I get this let I equals index, but I kind of lost the handle on my I. It goes from 1 to 5, so I had to remove it. So I removed the row number displaying here. And then, of course, my page controls that I added take an event and goes to the next page and renders the result. So the result looks like this. And you could render through the results using the page control. Okay, so stay tuned for part 2 when I put a router outlet here and start displaying the Google Maps in the outlet. I think that's simple enough. I don't know whether I'll use a mediator for communication or just use some other component communication, or whether I even need any kind of communication. But we'll take a look at that in our next demo. Thanks.